Abdurrahman Kashif, ID number W1986281, and this is my Applied AI coursework. I chose the segment of chatbots domain, and my prototype is intent classification for a retrieval-based customer support chatbot. I'm now going to start off with showing you my part A until part E, and I'll explain very briefly exactly what I've done in each section so you could understand what I've gone through and created. So, part A focuses on how artificial intelligence is used in chatbots, and in applied settings such as customer support, chatbots are commonly used to answer frequently asked questions, so FAQs, route user requests, and reduce the workload on human agents like us. In modern chatbot systems, they typically they typically follow a pipeline consisting of text pre-processing, intent classification, optional entity extraction, and response selection. I reviewed both rule-based and machine learning-based chatbots and explained why retrieval-based machine learning chatbots are widely used in practice and the problems to it as well. And I put them structurally over here as well so you could see, and the notable results and why intent classification is a good applied prototype. I wrote this, and through my research, I found out that this is particularly important because incorrect intent prediction directly leads to poor user experience. And so I concluded that this is why intent classification was chosen as the focus of the prototype and why it's more efficient and it's more better as well. I over here wrote the use of ChatGPT and how I used it to help in this coursework. It was intended to facilitate this coursework by one, helping with the planning of the report structure as per the marking rubric, and two, assisting the formulation and development of description, common chatbot architecture, and method of evaluation. And lastly, the generation of synthetic example sentences used in construction of the prototype intent classification dataset. No copyright data has been copied into the submission. All the data used in the implementation process in the notebook itself has been generated and will be used for its intended purpose of learning. I'm now going to move on to part B now. In part B, I compared and evaluated three AI techniques. One of them was TF-IDF with multinomial naive Bayes, MNB, and it basically discusses it basically discusses multinomial naive Bayes and how it's fast and efficient, but also relies on strong independent assumptions. Over here, I'm putting it separately, showing data requirements, setup, computation time, strength, and weaknesses of each of the techniques. The second one was TF-IDF with logistic regression. This was later chosen as in my prototype as well, which I'll explain why. It basically provides better class separation, stable performance, and good interpretability. These are the strengths, weaknesses, etc., etc. I'm now going to move on to technique 3, which was shallow neural network with multi-layer perception. This was implemented as a multi-layer perception, which can capture nonlinear patterns, but is more computationally expensive and less interpretable. Based on this comparison for all three, logistic regression was the best one, and it was selected for the main prototype due to its balance between accuracy, transparency, and efficiency. Over here is part C, and first of almost, this was the high-level architecture diagram, which was showing the viewer the complete pipeline. Basically, I designed the user input, text processing, TF-IDF vectorization, intent classification, and response selection with confidence-based fallback mechanism. Over here, I'm now going to maximize to show you exactly in detail what's going on and what's going where. Sorry. This is the runtime user interaction and what happens in the chatbot and the inside of it and how its mind is working while looking at the human inputs, question, and queries. This is the offline training and updates the chatbot has regularly to maintain itself. Moving on, the input data I created in a CSV file with two columns. I basically made the CSV file with in Microsoft Excel, and I'll explain this Basically, I made it with two columns, the user message text and the corresponding intent label over here. This is it. The dataset contains 2,600 samples across 10 intents and includes realistic variations such as spelling differences and ambiguous queries. The data then, I link this basically back into the notebook, pre-processed using lowercase and TF-IDF vectorization and split into training and test sets. Multiple models are trained and compared, after which logistic regression is tuned using cross-validation. The implementation produces classification metrics and a confusion matrix for visualization and a simple chatbot demonstration that selects responses based on predicted intent and confidence. So basically, I'm just scrolling through what I've done. This was the logistic regression for deeper exploration and the tuning of it. That's the result. That's the evaluation classification report and confusion matrix. Over here is the result. And this is the confusion matrix diagram. On the left, you can see the true label of all the outputs. This is the predicted label. These are the results. And yeah, this is the prototype demonstration going down. Data validation checks, maintaining everything. Golden set tests, expected correct results versus produced results. So what went wrong, what went right, what was it supposed to be, etc., etc. This showing pass, true or false. Basically a table. And now moving on to part D, software testing and evaluation. Over here, I evaluated the correctness and effectiveness of the implementation I made. I verified correctness using data validation checks, stratified train test splitting, and golden set tests, which with known expected inputs. And performance was assessed also using accuracy, precision, recall, F1 score, and a confusion matrix. The results basically shows that the model performs well overall, while some confusion occurs between semantically similar intents such as auto status and cancellation. These insights are useful because they highlight where additional training data or clarification prompts could improve the chatbot's behavior in real deployment. So when the real time comes, this section D over here tells us exactly what needed to be improved and what was right, what was wrong, etc., etc. Now this is part E, the equity, diversity, inclusion, EDI basically, and sustainability section. So over here was the bias, fairness, and accessibility ethics, where I talked about the dataset and how it includes variation in language style to improve inclusivity for different users, but bias can still arise if some user groups are underrepresented, basically. To mitigate this, the system uses a confidence-based fallback to avoid unsafe or incorrect responses, basically checking itself again and again. And from a sustainability perspective, the chosen model over here in this section, the chosen model perspective, the from a sustainability perspective, the chosen model in a computationally efficient is computationally efficient, and it runs on CPU hardware and has a low environmental footprint compared to large language models. That's section E done. These are my references over here. A big section is the last part of the document. So I want to say thank you very much for listening. I know I did stutter in some places, but thank you for taking the time and listening to what I had to say for my coursework. So I appreciate it. Thank you very much.